What is magma in geology? In geology, magma is a key component in the Earth's dynamic processes, particularly in the context of igneous rock formation and volcanic activity. Magma is a molten or semi-fluid rock substance found beneath the Earth's surface. It is derived from the partial melting of rocks in the Earth's mantle and crust. Here are some important aspects of magma in geology. Formation. Magma originates through the process of partial melting, where rocks in the Earth's mantle or crust are heated to a point where they become molten. This can occur due to increased temperature, changes in pressure, or the introduction of volatiles, such as water. The composition of the resulting magma depends on the type of rocks that undergo melting. Composition. Magma has diverse compositions based on the minerals and elements present in the original rocks that melted. The three main types of magma are basaltic, andesitic, and rhyolitic, characterized by their varying proportions of silica, iron, magnesium, and other minerals. The composition influences magma's behavior, viscosity, and the types of rocks it will form upon solidification. Movement and storage. Magma is less dense than the surrounding solid rock, causing it to rise toward the Earth's surface. It moves through the Earth's crust via conduits, which can include fractures, faults, and magma chambers. The movement of magma can create volcanic features like magma chambers beneath volcanoes, where magma accumulates before erupting. Eruptions. When magma reaches the Earth's surface, either through volcanic vents, fissures, or other openings, it is then referred to as lava. Volcanic eruptions occur when magma erupts onto the surface. The intensity and characteristics of eruptions are influenced by factors such as magma composition, gas content, and the presence of water. Eruptions can lead to the formation of volcanic landforms, such as volcanoes, calderas, and lava plateaus. Solidification. Upon reaching the Earth's surface, magma cools and solidifies, forming igneous rocks. The rate of cooling and the mineral composition determine the texture of the resulting rock. For example, slow cooling can lead to the formation of coarse-grained rocks like granite, while rapid cooling can produce fine-grained rocks like basalt. Understanding magma is crucial for geologists in deciphering the Earth's geological history, predicting volcanic activity, and studying the processes that shape the planet's surface. The study of magma provides insights into the Earth's interior and the dynamic interplay between the solid and molten components of our planet. How is magma formed in geology? Magma is formed in the Earth's interior through the process of partial melting, a key geological phenomenon that contributes to the creation of igneous rocks. The Earth's interior is divided into several layers, with the outermost layer being the crust, followed by the mantle and the core. Magma primarily originates in the mantle, although crustal rocks can also undergo partial melting. The formation of magma involves the following key aspects. Heat sources. The Earth's interior is characterized by high temperatures, and various heat sources contribute to the generation of heat within the Earth. The primary heat sources include the residual heat from the planet's formation, heat produced by the radioactive decay of isotopes within the Earth's mantle and crust, and heat generated by the gravitational compression of rocks in the mantle. Pressure conditions. The pressure within the Earth's interior increases with depth due to the weight of overlying rocks. As rocks move deeper into the Earth, the increasing pressure can elevate their melting point. However, certain conditions, such as the introduction of volatiles like water, can lower the melting point of rocks, allowing them to undergo partial melting even at elevated depths. Mantle composition. The mantle is primarily composed of ultramafic rocks rich in minerals such as olivine and pyroxene. These rocks have relatively high melting points. When subjected to increased temperatures and reduced pressure, as can occur in certain tectonic settings, portions of the mantle rocks begin to melt. Tectonic activity. Tectonic processes, such as plate subduction, mantle upwelling, and continental rifting, play a crucial role in magma formation. For instance, during subduction zones, where one tectonic plate is forced beneath another, water released from the subducting plate can cause the overlying mantle to undergo partial melting. This process produces magma that rises towards the Earth's surface. Crustal melting. In addition to mantle-derived magma, crustal rocks can also undergo partial melting. This often occurs in the lower parts of the Earth's crust in response to increased heat or the presence of volatiles. The resulting magma is typically more silicic in composition compared to mantle-derived magma. Magma composition. The composition of magma is influenced by the minerals present in the rocks undergoing melting. Magma can be broadly classified into three main types based on its composition: basaltic, andesitic, and rhyolitic. Basaltic magma is rich in iron and magnesium, while andesitic and rhyolitic magmas have higher silica content, resulting in different viscosity and eruptive characteristics. Migration and storage. Once formed, magma tends to be less dense than the surrounding solid rock, causing it to rise through the Earth's crust. Magma may accumulate in magma chambers beneath volcanoes or move through fractures and conduits before reaching the surface. Understanding the processes involved in magma formation is essential for interpreting geological phenomena, such as volcanic activity, the creation of igneous rocks, and the dynamics of the Earth's interior. It provides valuable insights into the complex interactions between heat, pressure, and composition that shape the geological features of our planet. What is the difference between magma and lava? Magma and lava are terms used to describe molten rock, but their usage depends on their location relative to the Earth's surface. The primary difference lies in their location and state. Location. Magma. This term is used for molten rock that is still beneath the Earth's surface. Magma can be found in the mantle or crust, and it is the precursor to volcanic activity. As magma rises towards the surface, it can accumulate in magma chambers beneath volcanoes or move through conduits and fractures in the Earth's crust. Lava. Once magma reaches the Earth's surface through volcanic vents, fissures, or other openings, it is referred to as lava. Lava is essentially magma that has erupted and is exposed to the atmosphere. State. Magma. Magma exists in a molten or semi-fluid state, with its temperature and composition varying depending on the rocks that have undergone partial melting. The composition of magma can include minerals like basalt, andesite, or rhyolite, resulting in different properties such as viscosity and gas content. Lava. Lava is also in a molten state, but it has been extruded onto the Earth's surface. The temperature of lava can range from extremely hot to cooler, depending on factors like the composition of the magma and the distance it has traveled from the volcanic source. Behavior. Magma. Beneath the Earth's surface, magma can move and accumulate in magma chambers. It can exert pressure on the surrounding rocks, leading to the potential for volcanic eruptions. The movement of magma is influenced by factors like temperature, pressure, and the presence of volatiles. Lava. On the surface, lava can exhibit various behaviors depending on its viscosity and gas content. Highly viscous lava, such as that associated with rhyolitic composition, tends to move more slowly and can form thick lava flows. In contrast, low-viscosity lava, such as basaltic lava, can flow more rapidly and cover larger areas. Composition. Magma. The composition of magma is determined by the minerals present in the rocks that have undergone partial melting. Different types of magma, such as basaltic, andesitic, and rhyolitic, have distinct mineral compositions and eruptive characteristics. Lava. Lava retains the composition of the magma from which it originated. Therefore, the composition of lava also varies, and it influences the type of volcanic rocks formed upon solidification. In summary, the main distinction between magma and lava is their location relative to the Earth's surface. Magma is the molten rock beneath the surface, while lava is the same molten rock once it reaches the surface through volcanic activity. Both terms are integral to the study of volcanology and the processes that shape the Earth's geological features.